Hello guys, so today I'll be explaining the Math AMS of Term 1, Week 4. Which of the following defines a function? A function, like if we need to know if it's a function or not, we do something called the vertical line test. Meaning, let's take the first one as an example. A vertical line goes from up to down. So we're gonna draw it, and if we find 2 points that meet on this line, then we know it is not a function, but it is a relation. So as we did for the first one, we know it's not a function. Second one, this one is a function because there are no 2 points that are on the same vertical line, so it is a function. This one is not a function because in this vertical line we have 2 points that meet. This one is also not a function because on this vertical line we have 2 points that meet. This is a function because there are no 2 points that are on the same vertical line. So that means the only 2 correct options are this one and this one. Question number 2. In the circle below, FE is a diameter. Now, if FE is the diameter, that means it will cut the circle into 2 semicircles. And we know that in a circle, the measure of the angles is 360 degrees. So if it's cut in half, then this will become 180 degrees. Okay, and another thing we can notice is that there's an inscribed angle. And the rule for inscribed angles is the measure of the arc over 2. So to find the measure of the inscribed angle EDF, we have to take the measure of the arc that it touches, which is this arc, okay? It is 180 degrees, but then we divide it by 2. So we get that this angle is 90 degrees, or it is right. So, based on what we explained here, let us see which of the following must be true. Angle EDF is an obtuse angle? No, we said it is right. Measure angle EF is less than 180? No, we said it is 180, so this one is correct. Then, EDF is a right angle? Yes, this is true. We found that EDF is a right angle because it is the inscribed angle and the arc that it touches is 180 degrees, so 180 over 2 gives us 90. They're telling us the measure of the arc is 90. No, the measure of the inscribed angle is 90. And finally, angle EDF is an acute angle? No. So we have only 2 correct answers for number 2. Question number 3. Which of the following functions are even? How do we know if a function is even? We have simply one rule. Fx equals f minus x. Meaning, let's take an example. X to the power of 2. We need to see if this is an even function or an odd, or like not an even function. So, we take, for example, x. Replace it in x squared. You're gonna get x squared. How about minus x? If you replace it in x squared, you're gonna have minus x squared, which is x squared. So now you have x squared, and the other answer is x squared. So they are equal to each other. So that means this function is even. We will like understand it more by solving the activities, the examples, sorry. So, which of the following functions are even? The rule for even functions is fx equals f minus x. Oops, the x will not write. F minus x. Okay. So, we have wx equals x minus 7 squared. There's no need to replace the x because it's already there as x. But now we need to take the minus x. So now instead of the x, we put minus x minus 7 squared. So if we expand both of them, for the first one, we're gonna get x squared minus 14x plus 49. For the second one, we're gonna get x squared plus 14x plus 49. They are clearly not the same because minus 14x is not equal to 14x. So this is not even. The second one, remember fx equals f minus x. We have x squared plus 7. There's no need to replace the x because it's already put for us. But let's replace the minus x. So minus x squared plus 7. So then become x squared plus 7. This and this are equal, so that means it is even. So this is an even function. Here, there's nothing to replace, so ux equals 7, but if you put minus x instead, so u minus x is also equal to 7, so that means they are the same then, so this is an even function. Now, this one. Okay, so this one. fx equals x minus 7 in absolute value. So again, fx is supposed to be equal to f minus x. So we have fx, let us do f minus x. So f minus x is equal to the absolute value of minus x minus 7. So definitely x minus 7 is different than minus x minus 7. So this is not even. Next one, we have this one. And don't forget, we have fx equals f minus x. We already have the fx or the gx or hx or ux or whatever. What matters is the x. So gx equals the absolute value of x minus 7. Okay. So then g minus x is going to be equal to the absolute value of minus x minus 7, which will then give us x minus 7. So this and this are the same. That means it is even. And finally, we have hx equals x to the power of 7. But how about h minus x? H minus x equals minus x to the power of 7, which is minus x to the power of 7. They are not equal, so that means it is not even. That was for question number 3. Question number 4. Which of the following functions are odd? So before we had even functions, now we have odd functions. Odd is a little bit tricky. Why? Because the rule for odd is fx is equal to minus f minus x. Or, in other words, let's write it in steps. The first step we replace with minus x. Second step, if it is not even, that means f minus x is not equal to fx, okay? We multiply by minus. We multiply the whole equation by minus. Third step, if it is equal to fx, so now first we replaced with negative x, but then it was not even because fx was not equal to f minus x. So what did we do? We multiplied the whole equation by negative, okay? So now if this whole equation is equal to fx, then it is odd. Okay, so we'll keep the rule in front of us. Fx equals minus f minus x. And remember the steps. Let's start with this one. We have x minus 2. If we replace if we replace the x with minus x, we're gonna have the absolute value of x minus 2. They're definitely not equal. So what does that mean? We have to multiply the whole of this equation by minus. So times minus, it will give us what? The absolute value of x plus 2. But x minus 2 and x plus 2 are not equal. So it's neither even, first of all, because this is not equal to this. And second of all, it's not odd because we multiplied it by minus and still it wasn't equal. So we say it's neither even nor odd. Second one, we have 2x to the power of 2. Let's replace the x by minus x. So 2 minus x to the power of 2 will give us 2x to the power of 2. So this is equal to this. That means it is even but not odd. So us, we only need odd functions, so we will leave this one. Second one, this one now. We have Rx equals 2. Then R minus x is also equal to 2. That means it is even for sure. But it's not odd, because if it is even, it's definitely not gonna be odd. The only case where if it's even and odd is that if fx is equal to 0, it's both even and odd. This is the only case that is both. But for now, we only need odd, okay? So this one is even, so we don't take it because it's not odd. Now this one, we have x plus 2 to the power of 2. Let's replace the x by minus x. Now we have minus x plus 2 to the power of 2. So that means if we make this bigger, we are going to have, if we expand it, we're going to have x squared plus 4x plus 4. And then this one will become x squared minus 4x plus 4. Clearly this one and this one are not equal, so it's not even. And we said if it's not even, we multiply the whole of it by negative. So then this will become what? Minus x squared plus 4x minus 4. So definitely this is not equal to this, so it's neither even nor odd. So we leave it. Now the last two, the second last, we have 2x minus x to the power of 3. If we replace it by minus x, we're going to have 2 times minus x minus x minus x to the power of 3, because we're replacing every x by minus. So then it will give us minus 2x plus x to the power of 3. Definitely this and this are not equal, so that means it's not even. Now how about if we multiply it by a negative? Times a negative. Then we're gonna have 2x minus x to the power of 3. So this and this are equal. That means it is odd because we multiplied it by minus, so it is odd. Finally, the last one, we have minus 2x to the power of 3. If we replace the x by minus x, we're going to have minus 2 times minus x to the power of 3. So that gives us what? 2x to the power of 3. Definitely this and this are not equal, so it's not even. But if we multiplied this one by negative, we would get what? Minus 2x to the power of 3. So this and this are equal, so it is then odd. So this is odd. Question number 5. Refer to the figure below to answer the question. What is the value of y? If you noticed from here, we have a quadrilateral inside of the circle, and it's not only inside, it's inscribed. And any quadrilateral that's inscribed is cyclic. And what does it mean, cyclic? Opposite angles are supplementary. So, if it is a cyclic quadrilateral, that means opposite angles are supplementary. So y, what's the opposite of y? 74. So y plus 74 is equal to 180. So y is equal to 180 minus 74. So this becomes 10, 6, 7, 106. So then the value of y is 106. Question number 6. Refer to the figure below to answer the following question. Here, we can take a rule directly, if you remember from previous solving, that the exterior angle is equal to the opposite of the interior angle. So here, the exterior angle is in green and the interior angle is in red. And what's the opposite of the red? It's 118. So that means this angle here is 118. And over here we have what? We have a triangle. And in a triangle, they're all equal to 180. So 38 plus 118 plus y is equal to 180. This plus this is 156. 156 plus y is equal to 180. So then y is equal to 180 minus 156. So then y is 24. Very simple. We got y as 24. Question number 7. If one angle of a quadrilateral measures 55 degrees, then the measure of the opposite angle must be blank for the quadrilateral to be cyclic. As soon as we see cyclic and opposite angles, we know they are supplementary. Okay, so 55 plus the angle that we will call y is equal to 180. So y is equal to 180 minus 55. Here's 10, 7. We get 125. Question number 8. In the figure below, O is in the center of the circle. And we have what? We have a quadrilateral that is inscribed. And inscribed quadrilateral, not any shape. It has to be a quadrilateral. Quadrilateral. We know that opposite angles are supplementary. So if they need us to find the value of x, and we have 2x plus 9 is opposite to x, we can do 2x plus 9 plus x is equal to 180. So then 3x is equal to 180 minus 9. 3x is equal to 171. 171 divided by 3, here we have 5. And here we have 7. So the value of x is 57. Question number 9. In the figure below, O is the center of the circle and KL is a diameter. We know that if KL is a diameter, that means this is 180, and the inscribed angle over here, it's an inscribed angle, it is equal to half of the measure that it touches. So it's touching the measure of 180. So half of 180 is what? 90. So we have this over here. And we know that in a triangle, the measure of the angles is equal to 180. So quickly we can do 4x minus 15 plus x is equal to 180 minus 90. So then we get 4x No, not 4x. We get 5x minus 15 is equal to 90. Bring 15 to the other side. We get 5x is equal to 105. So then x is equal to 21. Question number 10. Okay. Here we have two inscribed angles. They are touching the same arc. So, if they are touching, both of them, the same arc, that means what? They are the same measure. So then 6x has to be equal to 48. So then x is equal to 8. Question number 11. Okay, they're telling us if more than one such point exists, enter any of them. They need what makes the function one-to-one. So to make the function one-to-one, we have to do something called the horizontal line test. And so from its name, we draw a bunch of horizontal lines. And we see if there are 2 points on the same horizontal line, like here Q and U, that means it's not one-to-one, but they need us to make it one-to-one. So we either remove Q or U. So if you put Q, it's correct, and if you put U, it is also correct. Number 12. When defined over the set of real numbers, the function f given by fx equals 4 times x minus 2 squared minus 5 is not one-to-one. Okay, whenever you see a question like this and they're telling you that this function is not one-to-one and they need you to make it one-to-one by giving you a restriction, just like a quick summary, what do? You take the number in here and you take the opposite. So the number that is next to the x or behind the x, in this case, in the parentheses, you take it out and you take the opposite of it. So here it's minus 2 and the opposite of it is plus 2. So now this is the value of k. So our k is now here plus 2. For example, if we had 3x plus 5 squared minus 10, and they wrote all of this, but they just changed the equation. What is the value of k? We said we're gonna take the one behind the x, we're gonna change its sign, we're gonna take the opposite of it, so plus 5, the opposite is minus 5, and now we have our k. Question number 13. This one is not coming into in our exam because we didn't learn on to, but my teacher explained it. Basically, you see here, they're telling us A is less than B. And so we need to take a point where A is less than B. He said always take the highest point. Okay? So A is always the lowest point and B is always the highest point. So again, A is lowest point. In this case, it would be here. And B is highest point. So in this case, it's here. So then you draw this and you take the y because B means y. So then we have our B, which is 1. So the value of B is 1. So that was question number 13. Now question number 14. Again, question number 13 is not coming in the exam, so we shouldn't know it too much. Select the graphs that represent one-to-one functions. One-to-one functions, we said, for the functions we do vertical line test, but for the one-to-one we do horizontal line test. So let's do the horizontal line test on each and every one. This one, it's not one-to-one because we have 2 points on the same horizontal line. This one, it's also not one-to-one because we have 2 points on the same horizontal line. This one is not, because we have 3 points, not 2, 3 points on the same horizontal line. Then this one, it is one-to-one because we don't have any 2 points on the same horizontal line. This one directly we see we have 2 points on the same horizontal line, so it's not one-to-one. And then this one, it is one-to-one because there are no 2 same points on the same horizontal line. Question number 15, it's like we explained previously. We have 2 inscribed angles, okay, and these inscribed angles, they are touching the same arc, so then definitely they have the same measure. So x plus 55 is equal to 3x plus 45. Then we move this here, move that there. We have 2x is equal to 10, so then x is equal to 5. X is 5. Question number 16. For the domains, we have 4 cases. The first case is if it's a regular number, for example x, then the domain is all real numbers. It could be, for example, x squared plus 5. Also, the domain is all real numbers because it is a polynomial. It's not a fraction and there's no radicals in it. So as long as it's not a fraction and you see no radicals in the equation, then the domain is the set of all real numbers. The second case that we have is if we have a fraction. So for example, 1 over x plus 5. Okay, we know that usually in a fraction, it's impossible for the denominator to be 0. So that means the denominator, x plus 5, cannot be 0. It can be any number except 0. So x plus 5 different than 0, x different than minus 5. So it is the set of all real numbers minus, except, which means minus in this case, minus 5. This is how we denote it. Then, that was the second case. Now the third case we have is if we have a radical. So for example, radical x plus 2. We know in a radical, we can never ever have negative numbers. So, not equal to negative. So we cannot have a negative number in the radical. That means whatever the value here, it has to be greater than or equal to 0, because 0 is neither negative nor positive. So x plus 2 has to be greater than or equal to 0 because it cannot be negative. So x is greater than or equal to minus 2. Then that was the third case. Now the final case, which is if we have a radical in the denominator. So 1 over radical x plus 7, for example. We know already in the denominator, it has to be different than 0. And if it is a radical, it has to be greater than or equal to 0. But we have a contradiction. We have cannot be equal to 0 and we have or equal to 0. So very simply, what do? We remove the or equal to 0 here. And then we take out this polynomial, x plus 7. And then without the greater or equal, we just say x plus 7 is greater than 0. Why? Because it is in the denominator and it is a radical. So then we get x is greater than negative 7. So these are the 4 cases for the domains. Now, the domain of this is the set of all whole numbers? Definitely not. Why? It's the set of all real numbers. All whole numbers is only like 1, 2, 3. It doesn't include 1.5, 6.7, for example. It doesn't include these numbers. So it's wrong. This polynomial, its domain is the set of all real numbers. Now over here, we have a radical. So that means in the radical, we said it has to be greater than or equal to 0. So x plus 5 is greater than or equal to 0. X is greater than or equal to minus 5. So that means the domain of this is the set of all real numbers greater than or equal to negative 5. Now this is a contradiction to the one above, so we do not choose it. Then we have a fraction. We said the denominator can never be equal to 0. So x plus 1 is different than 0. X is different than minus 1. But here they said the set of all real numbers. No, it's not. It's the set of all real numbers except negative 1. So this is our answer for the fraction. And now for the polynomial, we have x squared minus 8x is the set of all real numbers except 8. No, it's the set of all real numbers including 8. There's no exception if it is a monomial. So the only true ones are this one and this one. Question number 17. This is an example of a relation that pairs elements from the set A to elements from the set B. So, in set A, which is our x, and set B, which is our y. Set A, we have only what? 3 and 9. Set B, we have 1, 3, and 9. So, if we take the first one, 1 and 3, we need in our x to have 1 and in our y to have 3. So 1, do you find it in the x? Directly from the first one, we don't find it. So that means the whole thing is false. Question number 18. Okay, they need the domain of this relation. The domain is the age. Always the one up is the domain, which is the x, okay? So the age, we have 13, 14, 15, 16, 17, 18, and 19. So we have the set of all integers between 13 and 19 inclusive. So now let's check the answers. Is it the set of all real numbers? No. Is it the set of all integers? Yes. What's the difference between real numbers and integers? Real numbers include fractions, decimals, radicals, but integers are the whole numbers. So this is correct. It's not the set of all positive integers. It's not the set of all real numbers. And it's not, here this one is correct if they removed the inclusive. But here it's the set of all integers between 12 and 20 inclusive, definitely not. Finally, we have 13, 14, 15, 16, 17, 18, and 19. So this is correct. That is for question 18. Now question 19. What must be the value of a for r to be a function? For something to be a function, each x should have one y. So for example, you have 3 and 5. You cannot have 3 and 6. Otherwise, it's not a function, but a relation. So they need what? They need a function. And a, we know that its x is 12. So we have to look in the whole set for something that has x is 12. This one. So we have 12, 23, and 12a. 12 is 12, and that means that 23 is a. So the value of a is 23. Question number 20. This is very simple. The only thing you need to do is replace the minus 2. So 4 minus 5 times minus 2, that is 4 plus 10. It will give us what? 14. Question number 21. This one, there are two ways of solving it. Either you take this number over here and you put it directly, or you replace the domain that is given to you. So for example, you have the domain over here is what? all numbers greater than or equal to 1. So replace with the number given, which is 1. You're gonna have 4 times radical 1 minus 1 plus 24. So 4 times radical 0 plus 24. So 0 plus 24, which is 24. And this is our range. So it's the set of all real numbers greater than or equal to 24. So here the answer is 24. Question number 22. They need the domain of H, and this is H. So we have a radical. We said in a radical that x has to be greater than or equal to 0. So if we move 84 to the other side, we're gonna have minus 4x is greater than or equal to minus 84. And whenever we are playing with the minus we have the greater than or equal, or the greater than less than, whenever we're playing with the minus, it will change this sign. So here, if we're gonna remove the minus from both sides, that means our equation will then become 4x, but this one will flip because we played with the minus, and then this becomes 84. So then x is less than or equal to 21. So this is our answer. X is less than or equal to 21. Question number 23. Okay, they need the domain of f and the domain of g. You just take the denominators, and because in the denominator it cannot be 0, we make it different than 0. X plus 10 different than 0. So when we are solving, this becomes 2x different than 50, x different than 25, and here we get x is different than minus 10. So for f, x is different than 25, and for g, x is different than minus 10. Question number 24. They need the domain of f. So also we have x squared minus 22x plus 40 in the denominator, and in the denominator they cannot be equal to 0. So what do? We factor it. I will leave that for you guys. So then it becomes x minus 20, x minus 2 is different than 0. Then you take each one and make it different than 0. So now we have x different than 20 and x different than 2. So the domain of f is all real numbers except 20 and 2. Question number 25. What is the value of minus 5 if fx is equal to this? So all you need to do is replace the x by minus 5, and then we solve. Here we're going to have negative 125 plus 20 plus 9. So minus 125 plus 29. We're going to get minus 96. So our answer is negative 96. Now question number 26, which is the final one, and it's always coming repeated the same. Now, very important, the number of students who play only tennis, not tennis in general. They're saying only tennis. They don't play any other sports. So which one is tennis? If A is our tennis, we need the ones that only play tennis and no other sports. It's this over here. So it is 9. Now the number of students who play basketball, not who only play basketball, who play basketball. So we take the full circle and then we add 10 plus 7 plus 2 plus 3. We are gonna get 22. And now finally, this is very important. It is what? A intersection B union C. Now, B union C is everything in B with everything in C. We finished B union C. Now we need what? The A intersection B union C. So what values in B union C are in common with A? We have 3 values, which are 7, 2, and 2. So very simply, we do 7 plus 2 plus 2. We will then get 11. So our final answer for this one is 11. Let's check. Thank you guys, and I hope you understood and have a great day.